Good morning, everyone, and welcome. This one is particularly near and dear to me. I used to be a controller product manager many moons ago, and it's been liberating to come to the cloud. I hope you will find in the next 40 minutes a playbook and an architecture you can use to define the network for the next decade for your wireless networks, right? Vintage cars are super hot. I love this picture. One of these days we'll be able to afford one, but vintage Wi-Fi is not. And so what you're going to see today is what are the trends in the industry? What constitutes the next generation networks, right? And how do you evaluate networks as we go through this journey here? So at the very beginning, this is the absolute best analogy of what is happening in our industry. 10 years ago, we had Garmin GPS systems in our cars. We loved them because they took us from point A to point B, liberated us off of the paper maps that we used to buy at AAA, right? They were great, purpose-built and did the job. One problem, if you ever had to update the map on a Garmin GPS system, it was an act of God. I never did it, while map updates probably came every 6 months or so, right? So the analogy here to our industry is that was the time when controllers were born. They were great. They liberated us off of the autonomous networks that we were building systems on, and centralized control and management truly helped us build large-scale networks, right? Unfortunately, just by virtue of the timing and the architecture are hard to manage. You have to rack and stack them. You have to maintain them. You are responsible for the upkeep and scale and resiliency of that. And then, came Google Maps and Yahoo Maps. Google and Yahoo Maps basically simplified how we consume the same use case, right? Going from point A to point B, we no longer were responsible for maintaining the system. And that's the analogy in our industry for that is Meraki. The launch of Meraki, was actually basically it's Meraki is cloudish, right? It was before the AWS era, a few servers in a data center in a shard, whatever. But they simplified deployment. They dramatically simplified operations from having to maintain controllers. But today, from truck drivers to cops to myself, I live about 60 miles from the office. If Waze tells me to drive backwards, I do, because this is the future. The future is sort of self-driving, self-learning applications. And that's where Mist comes in. We are trying to build an AI-driven, cloud-enabled, microservices architecture-based next-generation network that's for the next decade. So what we're going to do is we're going to take a sort of an industry view of this problem space, and along the way, I'll sprinkle in some demos for you so you understand what that means for all of us network IT, right? And so here's the favorite truism in the industry. The truism in our industry is, and all of us across the board, if you are maintaining a 10 AP lawyer office or 200,000 APs at some of the largest retailers in the world, the truism for us is the number of users, devices, applications, bandwidth is exponentially growing, right? And so now when this is exponentially growing, there's one other thing that's following this curve, that is the user's experience. User complaints have been growing. However, if you look at the last 7 years, I bet you haven't tripled and doubled your IT teams. If nothing else, the IT teams have stayed flat, maybe even declining. So in our industry, how do we bridge this gap? This is foundational. The only way to bridge this gap is using AI and automation. Quite that simple, right? And so that's why we are here today. So we're going to lay out a roadmap for, what does the network of the next decade look like, and what are the foundational building blocks for that, and the core tenets of the network of the next decade, right? So let's look at the foundational building blocks for the network of the next decade. Architecture. This is the most overused, abused term in our industry. Everything is an architecture, but this particular transition is very, very relevant for us. If you haven't read the book, Thank You for Being Late by Thomas Friedman, I urge you to read that book. It lays out the framework for a big transition that happened in our industry. 2007. 2007 is the year that the iPhone launched. And as Steve Jobs and actually Jeff Bezos calls this, the second industrial revolution, the renaissance of AI has started, right? Unfortunately, every one of the players in our industry, including the latest one being Meraki, were born before the iPhone was invented, right? So none of these architectures were able to take advantage of what a Facebook took advantage of, what a LinkedIn took advantage of, what a Twitter took advantage of, something called a microservices architecture built on the extensive, elastic, infinite Amazon Web Services cloud. That's where the future is. Mist as a company had the unfair advantage of being born in 2014 when a lot of this technology has come to bear. So what we're going to lay out for you today is, independent of whether you're choosing Mist or not, please choose cloud. Please choose a microservices-based cloud architecture, right? So now, why microservices? What is microservices? I'm going to take advantage of a video by Mike Jones from YouTube explaining traditional architectures are about, it's like spaghetti code. You have your RRM, you have your guest access, your client authentication, you have your, stats and reporting. They all are talking to each other. They all are talking to one database. It was one spaghetti monolithic code. Microservice architectures breaks that into small pieces. And today, Twitter is built like this. Amazon Web Services is built like this. Amazon themselves are built like this, where each of these microservices talks on one common high-speed parallel messaging bus called Kafka. Why do you want to do that? Why you want to do that is historically when you were transitioning from, controller image 8.2 to 8.6, right? You got one big monolithic blob and you don't know what changed. It's scary. And so you schedule downtime. You schedule a lot of outage for upgrading images. In the microservices world, two things happen. First, you're no longer responsible for maintaining your controllers. Second, these are bite-sized chunks, so we get to update them every so frequently. And that's what we've been doing. As an example, Mist leveraging microservices is able to deliver features every week. Let's talk about scale and resiliency. What has scale and resiliency meant to you? Historically, when you went from 1,000 APs to 1,010 APs, you had to buy more controllers, more redundancy controllers. It's all linear. But your business has become exponential. You deliver exponential scale with a microservices architecture, not with boxes in your closets, right? And so microservices lets you elastically scale the particular service that's consuming. If your location service is consuming, that elastically scales. But most importantly, you no longer are responsible for maintaining these boxes. Again, if you're making one decision out of this webinar today, make a choice that you no longer want to be responsible for boxes in your closets. Let the systems do the work for you. That's the power of microservices. Now, what does that mean in our current reality? In our current reality, I'll give you a simple example. When I was a product manager for controllers, customers would plead with me, partners would plead with me to say, you know what, I need this one feature. I have to deliver this. This particular business is bearing down my throat. I have to be able to do per user PSK with some micro-segmentation. We would take that feature back and we would go and sit with the engineering team and say, okay, let's go guys, we got to build this. But when I build that one feature, I have to test authentication, guest access, and this, and RRM, and everything, just because I don't know if any of those things are broken, right? And that's why it took us, anywhere from 6 to 18 months to release a new feature. That's the old world. You cannot build the network of the next decade like that, right? So what you want to evolve to is rapid agility, resiliency, and scale delivered by the cloud, okay? That's foundation number one. Make sure you write this down. Your next generation network has to be microservices cloud-based. Second point, this is very, very important, is AI and machine learning. What is Waze doing for us? It's quite simply saying, hey, somebody detected a cop, some car stopped on the freeway, just watch out, right? It's instant feedback, learning from the edges. That's what your network should do. The network shouldn't react on just transient changes, but it actually should learn over time and make your experience better. Machine learning has a very fundamental place in our business here in networking, and we're going to lay out a business case for that over the next 30 minutes or so. So AI and machine learning are foundational. But how do you build an AI-driven network? Here's what it took us to build an AI-driven network as an example, right? Number one, it starts with data. It starts with data because, as all of you know, there's one way to connect to a Wi-Fi network. You can, you authenticate, you associate, you do DHCP, you do ARP, you DNS, you're off to the races. But there's 130 ways to fail. You can fail because the fast roaming failed. You failed because you forgot the PMK ID. You failed because your roaming failed. You failed because your DHCP server was late. All of those types of failures existed in 2004, were just never collected, collated, and curated and maintained over a 24, 36, 72-hour period so that you can learn from the network, right? It started with data. Then, the best example, when we started with Mist, this particular story was inspiring for us. We deployed about a 40,000 AP network at one of our previous employers. CIO walks up Santana Row in the celebration dinner. He says, Sudhir, great job. APs are up and running, controllers are up and running. But Monday morning when my first consumer walks in, how do I know his experience is actually good? His website isn't taking too long to load. So when we designed the Mist user interface, we said it's going to be based on user experience metrics and user experience primitives. That's what this AI primitives is I'm going to show you in a demo. Then came data science. Data science is critical for us to be able to simplify our daily operations on a daily basis, because otherwise, we are repeating the same monotonous tasks every day. Every time a user calls in, we're repeating the tasks over and over again. We have to automate that, and we use algorithms for that. I'm going to show you some demos around that. And last but not least, Alexa, Siri, all of these virtual assistants are here to stay because they offer the power of the experts on your fingertips. And so your next generation network should have virtual assistants built in, right? So, and last but not least, and we're going to talk a little bit about this, it has to be self-healing. So what are the core foundational tenets of the network for the next decade? Here's 8 that we believe should be represented in every one of your RFPs and very likely and hopefully in every one of your networks, right? Don't build a network without one of these. Self-driving networks. I'm going to talk about radio resource management. Historically, radio resource management was, hey, there is some interference, there is some radar, or there is some overutilization, there's some capacity problems. I'm going to switch channels. That's RRM. That's the state-of-the-art RRM in the industry. But why not? Okay, let's say you made the change. Can you learn from that change? Can you keep the data on a per user basis over 24, 36, 72 hours and say, hey, RRM affected this change. Can I learn from that? Did the algorithm do right? So when you transition from machine learning to AI to reinforced learning to deep learning, that is the system learning from itself and affecting positive change every iteration. That's what self-driving networks are. That's what AI-driven networks are. Don't buy more controllers that can't even store data to do that kind of algorithms. Next, programmability. A simple one-line RFP requirement you should have in your next generation network requirements is 100% API-driven networks. Right? We launched a 1,500 store retail store, massive retail chain in North America. They gave us a simple Excel spreadsheet. We input all their site names and groups and addresses. automatically input all of them into the system, assign the right config for them, assign the right RF templates for them, assign the right floor plans, and boom. With no human intervention, we've onboarded them. That's the power of 100% programmability. There's a lot of systems out there that are doing bolt-on, doing DNA over old architectures, but they're bolt-on and they don't give you 100% APIs. And what you really need is APIs that are 100%, so that you don't have to fall back into CLI in the middle of a transaction, right? So half API, half CLI is not API. Agile, this is foundational. How do you respond to your users' demands of features, of fixes, right? We had the crack vulnerability in WPA2 come about for roaming vulnerabilities. Over the entire Mist ecosystem, of Fortune 100 customers to lawyer offices and credit unions, we've reimaged the entire Mist universe in less than an hour. You try doing that with controllers. Just doesn't work, right? And so we have customers that are still trying to get their controllers to be in the right image. Scalability should not be your problem. It should be our problem. We maintain the cloud. Resiliency should not be your problem, should not be solved with boxes. You cannot serve exponential scale, which is what your users are demanding, with boxes. The infinite box is the cloud. The elastic box is the cloud. That's where you need to solve resiliency. Security cannot be bolt-on. You cannot acquire your way into security with boxes and more boxes. What you want to do with security is embed it into the fabric, and that's foundational. I'm going to show you what that means. As I said, you should not belabor every problem manually yourself. Virtual assistants are the future of expert-driven systems, expert-assisted systems, and that's what you're going to have to do. That's what you're going to have to leverage and should be in your network. Last but not least, do not forget this. Your users are looking for great, amazing mobile experiences indoors. Right? Where is my closest conference room? Where can I find, I'm looking for a red bike in the Walmart. Where do I go find it? How can I be greeted when I walk onto a hospitality or a hotel? How do we get rich mobile experiences? The contextual experiences that Amazon delivers online, how do you deliver that in person? You need to do that without overlay beacons and overlay networks. You can do that using a fully integrated IoT-aware BLE-enabled system. And that's the power of Mist, right? So now, let me take each of these elements and talk through state-of-the-art today and what does the next decade look like, right? Self-driving networks, I already talked about radio resource management and how that needs to be AI-driven RRM. RRM as defined in the controllers, not going to cut it. It's like trying to drive with Garmin GPS when you have Waze on your phone. Why would you do that, right? AI-driven RRM is the future. Proactive alerting. One of our customers, 12:05 a.m. Particular Tuesday morning, we woke up because our proactive alerting system woke them up, and they found out that their network down, their distribution center was down. We went into the dashboard quickly. Within 5 minutes, found that it was their Windows devices on a particular SSID started at 12 a.m. and it was an authentication problem. It was certificates were failing in 5 minutes. We fixed the network because they pushed the wrong certificates. By 12:35 a.m., this is a Fortune 100 company, everybody was back in bed. The system woke us up before the users called in, and we were able to find, fix, and resolve them and get the network up and running in under 30 minutes. That's the power of an AI-driven network. Now, why can't you do this with existing architectures? Just count the boxes on the left-hand side here. Really, truly do. Not that you don't have enough boxes in controllers, in MSC, in ICE, in Prime. Now you have DNA Center, which needs its own sets of boxes. Every 4,000 APs, you need more DNA Center boxes. You need brand new APs, you need sensors. On the Aruba side, you need Net Insight, Clarity, Airwave, Ale, Meridian. More and more and more and more boxes. That's passé. Let's look at what an AI-driven network should look like. An AI-driven network should basically let me set service level expectations on my ability to connect, my ability to, the throughput we want to deliver in the network, the ability to do coverage, right? So every user, every minute, if we can take their average RSSI, put it in this histogram, and say over the last 7 days, 91% of the time, we delivered better than next 72 dBm, first time in the industry, we're doing a real-time site assessment of coverage everywhere. So then you say, and this is what I was talking about, that particular enterprise automated their entire deployment based on these service level metrics and said, hey, you know what? Successful connects is 95%. That sounds good. But then, what is the root cause of this? Is it DHCP? Is it authorization? Is it association? Let's go into it, right? Let's go inside and find out what is causing the primary issues around my network. Right? So again, in their case, what we did is we logged in. This successful connects, by the way, for them went from, a bunch of small trees to a tall tree here, and then suddenly a lot of failures, right? So we found out, okay, 12 a.m., all the failures started. Then we went into this distribution and said, hey, what WLANs is this happening on? For them, in their case, it was one particular WLAN. What devices? In their case, it was happening on the Windows 10 devices. And then immediately we said, what's wrong with the Windows devices? Let's go look at some of these devices, right? And so we looked at the exact devices that were having issues, right? And then basically say, let me find, say, so Mary Kate's iPhone as an example. Let's find that device and let's go look at that device's experience in the network, right? And so then we say, okay, wow, overall seems pretty good, but there were 5 catastrophic failures in her experience. And by the way, we have a dynamic packet capture waiting for us in the cloud. So think about what just happened. We didn't say, hey, Mary Kurt, go walk the hallway again so I can take a sniffer trace. Passé. That's when you build your network with boxes. When you build a network with the cloud, with a microservices cloud, the network is ready for you when you are ready to troubleshoot. Right? And so dynamic PCAP basically is helping you catalog every failure, right? So essentially, if you zoom out, an AI-driven self-driving network is proactive and it is self-driving. It will affect change, but it will learn from the change as it goes through. So let's go into the next piece, programmability. This is amazing. I was, especially an old curmudgeon controller product manager, we thought, wow, 1,500 sites, imagine doing that on one of our systems. And so, but then when we saw our API do this thing, it was just a piece of art. So, Mary Kate, were we doing a poll right now? So we're going to do a poll. I know many of you may not have 500 sites, but just for fun, play with this. So the question is, how long would it take for you to configure 500 sites? Best guess, using your Airwave, your Cisco Prime, your Ruckus Zone Director, whatever it is that you use today. You need to create 500 sites, assign configuration to 500 sites, and make sure 100% of them are validated and correct, and maybe even create floor plans and upload them, right? How long does that take today in your world, right? And so this is key. Why is this question important? This question is important because it's about automation. The one thing that you don't have one thing that you don't have right now is time. If we can give time back to you and save you from human errors, I think that's a win-win across the board. There you go. Several weeks, Maybe some people 1 week, and I think the Mist customer said less than an hour and less than a day. Good for you guys. But let's go back and look at what this customer did with us, right? So we created the RF templates. So this was job 1, created the config templates, job 2. Both of these are manual, we set up with the network. Then, but in the UI, can be done via API. Then we said, oh, just give me a list of an Excel spreadsheet of your site names and addresses and any groups you have. And they gave us a list of 500 sites. Obviously, we're using an anonymized data here. And then we wrote a simple Python script, which we are happy to share with all of you. In fact, if you are a customer of Mist, we will automate this for you. We launched a program called Mist Cares. We will do this for you. So then you run the API, and basically you're running through creating the sites, assigning the configs, and potentially even uploading floor plans, all of that kind of stuff. So let's go look at the audit log. Boom. We've created 500 sites with no manual intervention. Let's go validate that the groups are correct and the config is valid. The mantra for us is basically machines should program machines, and programmability means 100% API. Monitoring APIs are not good enough, okay? 100% APIs means no errors, okay? This is foundational. Let's go to the third one, agility. This is really, really important. This is your ability to respond to your business needs, right? And so what we have here is, as Mist, what we do is we deliver features every week. When your business says, hey, I need, private pre-shared key and or whatever, we deliver features every week, right? So every week. So last week, April 26th, was the last time we did a push, and we launched, creating walls on the location services for some of our location customers, right? This is critical. This is your ability to be reactive, be responsive to your business. And sometimes this is just as simple as, we launched, ability to set, site proxy URL on the APs, ability to set help desk admins to be able to replace an AP. Simple stuff, but you don't have to, call downtime. You don't have to take your network out of service as you're doing this. And you don't have to wait for months and years for feature updates and, more importantly, for bug fixes. This is the modern world. So demand that when you write your next generation network definition, that agility is a foundational tenet for being able to launch features rapidly. This is critical. And without you having to schedule downtime and do all of that stuff. Next, this is critical. This is huge. Being able to scale and being able to build resiliency into your system. These are two critical elements of building a successful network that works in the wireless LAN industry. And historically, what did we do? We used to basically stack controllers every time we need to scale and every time we need to build redundancy, geo scale and geo redundancy and all of this. That was painful. Because you are responsible from taking now, the more boxes you throw on the network, the more maintenance, the more images you're responsible for, the more network ports, the more power, the more compute. Why do you want to take this responsibility? That box architecture is done. And then let's lead to security. And again, the standard answer is with security is more boxes, right? You want some guest access with some basics, policy. You need ICE or you need ClearPass. You need some basic built-in application-aware policy. You need another box, right? So why? The more boxes you deploy, the grander and greater your attack vector is that you're opening for people to attack in your enterprise. Security, the number one core tenet of the next generation architecture, security has to be embedded in the system, right? So be able to do private WLANs, personal WLANs, be able to do WXLAN policies that are embedded, application-aware policies. Second thing, wireless IDS IPS. Never been more critical to do. Don't do with overlay systems. You shouldn't have to buy more licenses and more boxes to do, wireless IDS IPS. Archaic. But this is all today. Where is security evolving to? Remember, we talked about data science in the very, very first few slides. Data science is foundational to understanding the new security threats. A lot could be internal, but a lot is about behavioral. And so using horizontal data science algorithms to detect anomalies and to zone in on forensics on bad actors in the enterprise, you need a cloud and an architecture that can lend itself to it. Let me show what I'm talking about. So number one, if you are creating a network, and let's say, we had in our enterprise, one of the enterprise customers had they had a demand to say, hey, we are launching a new lab, we're doing some innovative products, we just need our own Wi-Fi, right? So then we said, okay, cool, why not? We've developed this feature in about probably less than 6 weeks. It's called personal WLANs, built into the product. And so what it does is it basically lets you create one SSID with multiple passphrases. And when you check this one box, it basically says, if I use passphrase 1, key 1, all my devices can see each other, but people that use key 2 cannot see the one, the network that is using key 1. So micro-segmented networks without VLANs and without belaboring, network architectures, we were able to just roll this in about I think a Fortune 17 company or something like that. We were able to launch in their enterprise without changing their wired architecture, security built in, right? Then they wanted policy. They wanted to say, hey, on my guest WLAN, I want Amazon video to be blocked, but I want HBO Go, whatever it is. I want application-aware policy built into my system. It's built into this system, right? Security should be embedded, not overlay. Overlay is bad, is more attack space and more maintenance for you. Last but not least, wireless IDS IPS should literally be a second click. Another click in this dashboard should be another microservice, should not be another box, right? And so then you say, hey, how do I detect neighbor APs? How do I detect honeypot APs? These are people masquerading my SSID. How do I detect rogue APs? And being able to actually generate, PCI reports for PCI compliance, and being able to see, what's going on with my PCI report, complete PCI report, everything built in, right? So this is the power when you build with an AI-powered network. Security is built in, right? So coming back to this, virtual network assistant. This is key. This is foundational because you shouldn't have to belabor every problem in isolation. One of the pet peeves for me when I was a controller product manager is we basically we would see customers, especially university customers. Every university, when the new semester starts or the new iOS image comes up, basically they are suffering through the same problems across the entire universe of customers. That seems so mundane, that seems so archaic that we would put all these customers through the same problem every time iOS released a new upgrade, right? So the future is a network assistant, a virtual assistant, an expert wireless assistant next to you. And so I'm going to tie this back to the original slide we started with. The gap we're trying to bridge is user complaints are exponentially high and IT staff are shrinking. How do we actually bridge this gap? With virtual assistants. So let me show you what a natural language aware virtual assistant looks like so you can ask expert questions of your network, right? So let me do a quick into the demo. And by the way, Don't deploy another overlay box and box and box for this. Just click in another menu item here. That's pretty much it. And ask the question, hey, what is wrong with client, let's say, it's Sujay, yes, last week, right? So simple questions, simple ability to answer. Now, what did the system do here? What the system did is it analyzed 7 days worth of data for Sujay's device. It analyzed 7 days worth of data on all the APs Sujay connected on. It analyzed 7 days worth of data of all the types of devices that are similar to Sujay's iPhone 6s. And then it analyzed all the devices at a site level at the particular site Sujay's device connected at. Today, you do that manually. Right? When we do that automatically, that means we are collecting, collating, curating, and machine learning on all of this data in one fell swoop. So let's look at what the answer came up, right? So the answer says, hey, Sujay was not having any connection problems. That's great. He's having some throughput issues because we have limited RF capacity. As you can imagine, we run a lot of tests in our space here. Our QA team is always hammering our RF. And so, yeah, we've had some capacity issues affecting a few clients. And also it says, you know what, Sujay's device is suffering from some coverage issue, but it's specific to him. He must have the corner office, and that's why his device is suffering. It's not generic. It's not affecting everybody. So imagine if you knew whenever a user called and said, hey, my wireless sucks, we were able to say, you know what, that's a user-specific issue, or it's not. That's powerful to say. Then you say, okay, let me go investigate what is going on with Sujay's iPhone 6s throughput experience. What is, let me build this out here. What is all the devices, all the things that are happening? What's the average throughput we are delivering to Sujay's iPhone 6s? This is not what he's consuming. This is what he could consume if he wanted to. This is available throughput for his particular device. And this is the histogram of available throughput that we are offering to the device. And then we're saying, did he suffer from any WAN outages? No. Did he suffer from, a device that's incapable of 40 megahertz or 60 megabits? No. He's having some coverage issues and he's having some capacity issues, and we know exactly what time of day and what time of the day of week it was happening. We also know what SSIDs and what APs it's failing on. What relative to the site-wide failure, what is the client failure, right? And so that's why it's saying, hey, no, there's more people at the site failing on this versus just the individual client. And this last one is my favorite, guys. If you've ever managed a controller, what is the last thing you want to hear from your tech whenever you open a customer support ticket? The last thing you want to hear from them is, you know what, upgrade to the latest image. It fixed all your problems. That's been the bane of our existence for a long time. Wrong answer, because that means I have to now schedule downtime, take my business offline and upgrade to controller. However, people are free to change config changes on the system. And historically, we had no idea whether a config change actually helped the system or hurt the system. And so here, we're saying, did any of your APs reboot? No, that's good. That chart being empty is a great thing. No kernel panics, no software reboots. And then, did RRM change channels? Yep, RRM is changing channels. Did somebody make some config changes? Yes, Sunalini has been busy making some config changes. And so now you can collate all of this. You don't have to go to 50 different systems to bring that all together. And then last but not least, overall, his connection experience has been pretty good. A lot of very good experience. And then, a couple of bad things on the event side. So this is the power of a virtual assistant looking out for you and answering questions. You can ask this at a site live. you can say, what is wrong with, the site office production, right? Last week. And so now you can ask this question at a site level, right? You'll be able to see what is going on at a site-wide level. Somebody asked the question, does Marvis look at spectrum? Absolutely it does. Because we look at, non-Wi-Fi interference, we look at co-channel interference, we look at the AP load by itself when we compute available capacity and coverage, right? And so absolutely we look at non-Wi-Fi interference and it will be factored in here. If we were having non-Wi-Fi interference, it would actually say that your throughput is low because of non-Wi-Fi interference. Here it's saying, your time to connect at your site is low, is slow because you have a slow DHCP server, unresponsive DHCP server, right? You can ask all kinds of cool questions like this. One of the users, this is a great story. We deployed the network at one of our customers, and we replaced in a Ruby network or something, and we deployed the Mist network, and they're like, you know what? Mist is no better than the network we had. Users are still complaining. Then we said, guys, our SLEs are showing some DHCP failures. Let's look at what DHCP servers you have. And we just ran this command. We said, show me your DHCP servers. And they said, oh, they're not our DHCP servers. Well, they're serving IP addresses on your network, so they must be somebody's DHCP servers on your network. Long story short, here's what was happening, was plaguing them, and they didn't even know. Users were getting DHCP IP addresses from their lab network, and they were getting full 5 bars on their Wi-Fi system, and still they can get nowhere. So what do they say? I have 5 bars, coverage is great, but Wi-Fi sucks. And as soon as they saw that their lab network was routed to the corporate network, by the way, Fortune 100 company, fixed it, boom, Wi-Fi works, right? And so as network IT and wireless IT, you always know, the mean time to innocence is basically how fast we can prove that it is not the wireless network, right? That's the mean time to innocence. That's what's shortened by the virtual network assistant. So that's what you need in your network of next generation. Let me culminate this with user experience. We have so many people, so many employees, guests, patients, passengers asking for an enriched indoor experience, right? And what does that mean? We have multiple customers, Fortune 500 customers that are deploying employee mobile apps saying, reserve conference rooms, find the closest conference room. We have retailers deploying an associate persona mobile app and a customer persona mobile app. As the customer walks into the store, it says, hey, welcome John Smith. We know Fluffy has an appointment at 10:30. He's already checked in. Let's take him in, and you should go shopping. All that kind of, patient, passenger, guest, employee experience, we can deliver with Bluetooth Low Energy, right? And again, by the way, no more boxes. If nothing else, just write this down on your wall, in your NOC. No more boxes, right? And so location, should be delivered integrated. And here's what you're seeing with the system, where you can actually see, mobile app users, Wi-Fi connected users, Wi-Fi unconnected users, BLE passive clients and BLE active clients. Ability to basically see and just assets around the office to say, or employees, when you issue an evacuation of the building, employees always have 2 things on them. Employees almost always will have their cell phone on them. They may not have their wallet on them, and they almost always have a badge on them. And the badges now have BLE in them. So you can actually enable security applications with asset visibility with an AI-powered network. This is an example of one of our users that launched an application. And look at what a cloud-based location application can deliver with respect to mobile engagement. This is a hospital, and here we are walking smoothly. If you've ever deployed wayfinding using Wi-Fi or overlay systems, Please don't do that anymore. Do yourself a favor, take those systems down, trade them on eBay, but get to a cloud-based location system. 1, 2, 3, the guy turned the corner and the blue dot is there. Less than 3 seconds in latency on a real-world application. This is the power of an AI-powered microservices cloud for enabling mobile applications, right? So this is what our customers are deploying as they're thinking through this, right? So to summarize this, a microservices cloud will give you self-driving, AI-driven feature set that is needed to save you time and simplify your operations. Programmability to launch and operate your network simply and easily. Agility so you can react to your business every day and not wait 6-month cycles for feature updates. Scalability so you are not in the business of boxes, and resilience so you are not in the business of boxes, right? Security where it is embedded, virtual networks so experts are with you with a shoulder around you, with an arm around your shoulder saying, we got it. We are evaluating all the possibilities, doing the correlations. Last but not least, amazing user mobile experiences. You should never do battery beacons, and you should never do single chip BLE things costing in $2,000 APs. They are archaic because they can't deliver either the scale, the agility, or the real-time response of location systems that are built in the cloud. So my urge to you is the following. There are a lot of boxes in your system already. You may have all or some of these. If you're Aruba, Cisco, Ruckus, doesn't matter who you are. You have a location system. You have a policy system. You have an assurance system. If you haven't bought one, you're probably buying one or you're getting one for free because they want to try you to try it. You have some data aggregation systems. And last but not least, you have your controllers. It's not the box's fault. They were great. They were purpose-built. They served their time. It's now time to put them in the Hall of Fame. It's time to retire your boxes. It's time to retire your controllers. We hope you enjoyed this. We hope you come to see a demo of the full Mist product to be able to understand what next generation networks are, why Fortune 100, Fortune 500, Fortune 2000 customers are abandoning their existing massive installed base because there is a better tomorrow, because there is Waze and you don't need Garmin anymore. Mary Kate, that's it. I think we're good to go. Thank you very much, everybody. Have a great day, and thank you for joining the webinar.